sorry guys, I forgot to record this before I started. We're going over the type of exponent rules. So get this set up and then we'll get going. All right, the first kind of exponent rule that you're gonna see is when you're multiplying exponents. Okay, so multiply. And when you're multiplying exponents that have the same base, you're going to add the exponents. Okay. And what this looks like is if you have like x to the negative 2 times x to the negative 3. The bases are the same, and these are being multiplied together. So the rule for this is that we can add the exponents. So this will be x to the first power, or just x. Okay. In the answer checker, I will not have the 1 there. You're going to want to make sure that you don't put that 1 either. Just assume that if it's to the first power, it's just one variable. Okay. The next type of exponent problem that you're going to see is dividing. Okay. And in that case, we subtract the exponents. So assuming that we're dividing numbers that have the same, dividing exponents that have the same base, we're going to subtract the exponents, or the power, whatever you want to say. For example, if you have x to the negative 2 divided by x to the third power, we can subtract those exponents, okay? And this is where a lot of people make mistakes. It's integer errors when they're doing this. So it's negative 2 minus 3. So this will be x to the negative 5. And just a reminder, that negative exponent is telling you that this whole thing should actually be in the denominator, okay? So I can rewrite this as 1 over x to the 5th as well. I will accept both answers tomorrow. Just make sure that you know that that negative exponent means that it needs to actually be like this. So just have that information, okay? And the last type of rule that we are going to encounter is when you have exponents to a power. Okay. And that's when you have an exponent to another power. And in that case, we're going to multiply the exponents. So an example of this would be x to the negative 2 all to the third power. So when you have a power to a power, we're going to multiply those exponents. So negative 2 times 3 is a negative 6. So this will be x to the negative 6. You can leave it like this, but you should also know that that negative exponent means that it actually looks like this. That negative exponent tells you that it's supposed to be on the other side of the fraction bar. Okay, I'm going to do a quick example that involves all of these rules in the same problem, so we can just make sure it's super clear. And then I'll show you, just do a quick thing about scientific notation. wanted to make sure that you saw this power problem with a lot going on in the middle here. There's a couple different strategies that you can do here. You can distribute the 3 to everything first and then simplify it, or you can simplify what's in the parentheses first and then distribute the exponent. Megan? Yeah. Good question. Just to be consistent, because I always say distribute first. I'm going to go ahead and distribute first. Okay. So what that means is this is going to become 3 to the third power. X to the -3 times 3 is -9. Y to the 12th power. And then anything to the 0 power is just 1 anyways, but if we just multiply the exponents like we're supposed to, this will be x to the 0 still. Because 0 times 3 is just 0. And I also have to distribute it to this too, because the parentheses are around the denominator as well. So this will be y to the third. Okay. Now I can go through and simplify. So 3 to the third power is 27. I'm going to condense my x exponents. This actually just has a value of 1. But if we leave it like this and just add the exponents, again, it will just be to the -9. And my y's, I'm going to subtract. So 12 minus 3 is 9. So this will be y to the 9. You can leave it like that. That's fine. Or you can move this -9 down to make that exponent positive. And that would look like this. Like that. All right. So let's take a look now at, is there any questions about this stuff? Cal, how did I get 27? 27y to the 9th? Because I subtracted my exponents here. So this is y to the 12, y to the 3. So when I subtract them, I get y to the 9th. You got it? Okay. Anyone else have questions? You good? Okay. Then let's talk about scientific notation. Yeah. Ooh, I need to zoom out a little bit too. For scientific notation, it's pretty straightforward. I'm just going to do 2 examples just to refresh your memory. Because some of you were doing some crazy stuff on your calculators trying to figure these problems out. And the whole point of scientific notation is that you can do it because your calculator only has a certain number of digits it lets you plug in. And so I'm showing you how to do it in a way that your calculator can do. So if you remember back to when we did this, we multiply those numbers together first. So we're going to do 4 times 7.1. So what we get when we multiply that together is we get 28.4 times 10. And when you're multiplying exponents that have the same base, what do? You add. So what should my exponent be on this? -4. Awesome. Now, if you give me this answer, you will not be able to get mastery. Because this number right here needs to be between 1 and 10. So if you multiply these together and then add your exponents and everything, and this is not between 1 and 10, we have to move the decimal place. So if I move the decimal place and make the number smaller, my exponent gets bigger. Fabulous. Okay, so this is the answer that I'm looking for, and I want it to be in scientific notation, okay? If you're trying to do this in standard form, you're going to make mistakes because there's so many like place values. So just keep it simple. Keep it simple. Okay, so that's an example of multiplying. Now let's take a look at an example where we're dividing. Okay. So I'm going to divide these numbers first. So this is going to be 5.6 divided by 8.21. Okay. I can already see that I'm going to have to move that decimal place over, but first of all, I'm going to round to the nearest hundredth. So this is going to be 0.68. Okay. And then I need to subtract my exponents because this is division. So this will be 10 to the third. Oh, you guys, I already made a mistake. Because if I want it to be rounded to the nearest hundredth, and I'm going to be moving my decimal place, then I really should round it to the nearest thousandths. Okay, so I'll do that. Now, this is awesome, but this isn't mastery. If we want mastery, we need to move our decimal place to make it between 1 and 10. So if I make my number bigger, my exponent gets awesome. Okay. So this is what I'm looking for right here. Okay. Yeah. Yeah, and I'll let you know. I'll be pretty flexible on the test. I mean, I don't want you guys to put every single digit, like all of this on there. But if you round to the nearest hundredth, the nearest thousandth, that's fine. And I'll be pretty flexible on that one. Yeah, but I will probably also put in there like, hey, round to the nearest hundredth. But if you round to the nearest thousandths, it's fine. Any other questions? Okay. Now with exponents, sometimes this exponent unit, sometimes there's a lot of different ways you can put it in the answer checker. So if you are super sure that you've gotten something right and the answer checker is telling you wrong, please let me know or email me right away so that I can take a look at your answer and see if it's correct and put it in the answer checker for the other people too. Okay, so there's a chance the order might not be in there the way that you ordered it, but your answer is still right, so I want to make sure it's in there. All right? Like I said, I'll be in here during lunch. I'll be here after school. I'll be here tomorrow morning. So if you need anything, come in and see me. And you guys have about, 20 minutes to work? Yeah. All right, get busy.